So the acceleration of A, equals 0.18 t. And A, we must know, is dv by dt. That is the gradient function of the velocity time graph, which is what we got here. Okay. And it says other bits. A starts from rest and follows that acceleration. B has got something here, then it goes constant. And they actually, at this stage here, they collide. So that bit there, they must have gone exactly the same distance when they collide at 16 seconds. So, first part, calculate the value of t for which particles have the same velocity. Or when they got the same velocity is up here. When they got the same, obviously they've got the same velocity there. And the velocity is 9. So that's what I'm going to do. I'm going to find out when A has got a velocity of 9. So first part, so I'm just looking at the A bit. So I've got dv by dt equals 0.18 t. And so I want to integrate both sides with respect to t. That will give me that velocity equals t is going to have to, power is going to have to increase, and that'll be 0.09. Just check. 2 times 0.09 does give me that, and power decreases to get that. Don't forget, always plus c. And then we need to find by c by putting the condition in, and we know here at 0. So when t equals 0, v equals 0, so that's 0, therefore c equals 0. But we do want to work that out. So now I know that v equals 0.09 t squared, and I want to find out when it equals 9. So 9 equals 0.09 t squared, so therefore t squared equals 100, and so t equals 10 seconds. Well, that's nice, so I could put in 10 on my diagram there. Don't know if I need it, but I might well do. So that's the first part. What have we got for the second part? 2. Between 0 and 5, the distance of B from S is that. So that's the distance. So that's what x equals. So for the first part of the journey, x equals ut plus 0.08 t cubed. That's what x equals. Calculate u. So I've got to work out this bit. Must be something else about this. Oh, and verify that when t equals 5, b is 25 meters from S. So I'm going to show that that distance there is 25 meters. So what have I got? Got this bit there. It's all to do with velocities. So I need to get a velocity. So I need to do v, and that equals dx by dt. So differentiate that. That gives me u plus 3 times 0, that'll be 0.24 t squared. And when t equals 5, velocity equals 9. So then hopefully that'll do it, won't it? V9 equals u plus 0.25 times by 5 squared. And so u will equal, that comes to 3 meters per second. That's nice. And we've got to try and work out and do this verifying. So when t equals 5, the distance x equals from up here ut, so it's 3 times 5 plus 0.08 times by 5 cubed, which equals 15 plus 10, which equals 25 meters, which is what I wanted to verify. Part 3, let's go purple. Part 3, calculate the velocity of B when t equals 16. So I want to know how fast B is going when t equals 16. So that's when they collide. So what I need to do is I need to find out how far A is gone, and then I can work out how far this is. Because I know that's 25 meters, and from 5 to 15, that's 10 seconds there by 9. So that bit there will be 90 meters, plus the 25 meters to start off with. This distance here has got to add up to whatever my total distance is. So the first thing I need to do is find distance travelled by A. And distance will be the area underneath that graph. So it'll be the integral between 0 and 16 of that, what V is, and V I've got worked out here, 0.09 t squared. So 0.09 t squared, and so that will equal, it's got to be t cubed, and it'll be 0.03 t cubed between 0 and 16, and that will equal, put 16 in, which would give me 122.88 meters, minus putting 0 nothing, so minus nothing, so it just equals 122.88 meters. And now we can work out what we've got. We know this area here, so if I call this, I'll call it D, I don't know why, but I'll call it D. So we know that D must equal 128.88 minus the 25 from the first part of the journey, minus the 90, which is the rectangle bit in here, the constant speed, and that equals 7.88 meters. And now I'm going to look at it geometrically. You could obviously use a formula, but since I've got a velocity time graph, I'm thinking geometrically. I know that that's 9, and I've got to find out what that is. It goes from 15 to 16, so that distance there is 1, and that area of that trapezium is a half, or the average of the two parallel sides, so 9 plus V times by distance between them, which is 1, and that equals 7.88, and that will come down to 9 plus V equals 15.76, so V equals 6.76 meters per second. And that actually looks quite reasonable as well. Always just check, it's going to be less than 9, isn't it? It looks good. Hopefully